1,000 degrees Fahrenheit, a temperature that can make steel soften, yet ceramics remain standing without a single crack. This material, which seems so fragile, has endured for thousands of years, from ancient jars to bowls, floor tiles, and even components for modern industry. Beneath its glossy surface, every ceramic product undergoes a complex journey. Clay is extracted and purified, shaped into its skeletal form, dried, and then tested by fire multiple times inside kilns blazing at thousands of degrees. Afterward, layers of glaze and intricate patterns are applied, transforming everyday objects into pieces of culture and history. In this video, we will dive into each stage to uncover how ceramics, the material that is more fire-resistant than steel, are produced on an industrial scale. Raw material extraction. The journey of ceramics begins in natural mineral deposits where clay, kaolin, feldspar, and quartz are extracted under strict quality control. The topsoil is removed by large excavators and bulldozers, exposing the main mineral layer, located about 10 to 30 feet below the surface, depending on the type of mineral. Workers use backhoe excavators, graders, or block cutters to separate each layer. Large chunks of material are then loaded onto dump trucks weighing several tons and transported to the pre-processing area near the mine. Here, the raw materials are roughly crushed to reduce their size and washed with high-pressure water jets to remove soil, sand, roots, and gravel. Certain minerals, such as kaolin or feldspar, undergo additional washing in circular filtration tanks to separate the fine fraction and eliminate iron-bearing impurities, which helps increase the whiteness of the final ceramic product. Once cleaned, the materials are air-dried or lightly oven-dried before being shipped to the manufacturing plant. Inside the factory, each mineral is precisely weighed according to the blending formula. All components are then fed into large mixing tanks where they are combined with water to form a smooth clay slurry. For dry press technology, this slurry is spray-dried to create fine powder granules. In extrusion technology, the slurry is filter pressed to form plastic clay blocks with the right moisture content. These clay blocks are transferred to a pug mill or extruder, where they undergo final kneading to remove trapped air and achieve ideal plasticity, ready for the next stage in the production of clay blocks, ceramic pipes, or refractory materials. Extrusion is widely used for its stability and ability to form precise shapes. The moist clay mixture, after thorough kneading, is fed into a screw extruder, where a large rotating screw gradually compresses and pushes the material toward the die. The pressure is just enough to force the material through a metal mold, shaping it into a long, continuous column with a uniform cross-section. The mold can be manually changed to produce different profiles, from rectangular bricks to round tubes or solid shapes. As the clay exits the die, operators visually and manually inspect it to ensure the surface is smooth and free of cracks or shrinkage. The continuous clay column then moves through a clay cutter where thin steel wires or sharp blades slice across it into equal length billets. The operator must frequently adjust the cutting speed and wire tension, as even small variations can cause uneven edges or distorted shapes. In many factories, workers still fine-tune the conveyor speed and spacing of the cutting wires by hand, because a deviation of just a few fractions of an inch can result in misshapen billets or rough surfaces if the blades stick to the clay. Cutting with a machine ensures consistent dimensions across thousands of pieces, but the process still depends on the craftsman's trained eyes and steady hands to keep every setting precise. Ceramic production process. After the raw materials are ground, blended, and reach the right plasticity, the forming stage begins. This is where each ceramic product takes on its initial shape. In factories producing household items such as bowls, plates, and dishes, the jiggering technique is the most commonly used. Basically, jiggering combines a rotating plaster mold with a thin, pre-shaped metal blade. As the mold spins steadily on the machine, the operator places a lump of soft clay in the center. The blade then moves smoothly, pressing and trimming around the clay as it rotates, gradually shaping the walls and interior of the piece. The whole process takes only a dozen seconds, but requires high precision. The rotation speed, blade pressure, and clay moisture must all be carefully adjusted. This method ensures that every bowl or plate has the same thickness and curvature, even in large-scale production. For more complex forms such as vases, teapots, or decorative jars, factories use the slip casting method. Liquid clay, or slip, is poured into plaster molds where the water gradually seeps through the porous walls, leaving a solid clay layer that thickens over time until it's strong enough to remove from the mold. Alongside industrial production, traditional hand throwing remains part of the process, connecting craftsmanship with modern technology. On a potter's weir, artisans center the clay using their hands and water, then press, pull, and shape it upward into bowls, vases, or jars. Every curve is adjusted manually, guided by the artisan's touch and experience, a process that keeps the human element alive in the art of ceramics. The freshly shaped ceramic body still contains a lot of water and remains weak, so the drying process is carried out to stabilize its structure. Bowls, plates, vases, and jars are placed on racks and moved into a circulating heat drying chamber, where the temperature ranges from 140 to 250 degrees Fahrenheit. Hot air circulates evenly through a system of fans and humidity sensors, allowing moisture to escape gradually from the outside to the inside in a balanced way. In modern factories, robotic arms pick up the pieces and place them onto continuous drying conveyors, saving time while ensuring that every item in the batch reaches the same level of dryness before moving on to the next stage. The dried ceramic pieces, now structurally stable, are sent directly into the kiln for their first firing, known as the bisque firing. The goal at this stage is not to achieve maximum hardness, but to remove all remaining bound water and organic impurities. As the temperature gradually rises, the mineral particles begin to tighten and fuse slightly, forming a temporary but solid framework that still retains enough porosity for the glaze to adhere firmly later on. In large factories, the bisque pieces are placed on conveyor belts that move continuously through long tunnel kilns, where the heating zones are divided into preheating, soaking, and cooling sections. Some production lines are also equipped with exhaust and ventilation systems to remove smoke and moisture, ensuring that each piece comes out clean and evenly conditioned for the next glazing stage. After the bisque firing, the ceramic body moves to the decoration stage, where patterns and colors first come to life. In traditional workshops, bowls and vases are hand-painted with fine brushes and mineral pigments. Artisans carefully paint each line in detail, from floral motifs and calligraphy to landscape scenes, directly onto the unglazed surface. Once finished, these decorations are left to air dry naturally before being coated with a layer of glaze. When production scales up to the industrial level, the decorating process becomes fully automated. Bowls and plates are placed upside down on rotating holders, while robots handle the printing or spraying according to preset programs. Many factories use decal transfer printing machines, where patterns are pre-printed on a thin film and then pressed onto the ceramic surface. On top of the mold is a soft rubber pad coated with ceramic ink containing the design. As the machine lowers the mold, light pressure transfers the pattern evenly across the surface of the piece. This controlled pressure and mild heat allow the print to adhere perfectly even on curved areas or rims. Afterward, workers manually inspect each piece to ensure the design is aligned and free of wrinkles or excess ink.
This printing method can reproduce complex patterns within seconds, far faster than hand painting, while still maintaining the refinement and consistency that define high-quality ceramics. After the decoration is complete, the products move to the glazing stage, a coating process that determines the gloss, smoothness, and water resistance of the ceramic. In many factories, this step still follows the traditional principle: dipping the product into a bath of liquid glaze. Bowls or cups are fixed onto rotating holders and slowly lowered into the glaze tank. The glaze mixture, made from finely ground minerals diluted with water, has a smooth, viscous texture that allows it to coat evenly over the surface. As soon as the ceramic touches the glaze, a thin layer adheres within seconds. The holder then tilts slightly, letting excess glaze drip off, ensuring a uniform thickness across the entire piece. On automated
Moved to the final firing stage, where the coating and the clay body fuse into a single solid mass. The temperature at this stage typically reaches 2200 to 2500 degrees Fahrenheit, hot enough to melt the glaze and bond it tightly to the ceramic frame. In large-scale factories, the products are neatly arranged on heat-resistant conveyor belts that move continuously through tunnel kilns, stretching dozens of meters long. Inside the kiln is divided into several zones: heating, soaking, and cooling, forming a precisely programmed temperature curve. One distinct feature of these kilns is their arch roof design, which allows heat to circulate evenly, preventing hot spots and reducing warping. Gas burners or electric heating elements are installed along the kiln's length, supported by a forced air circulation system that ensures no cold or overheated areas develop. Throughout the process, infrared sensors and automatic controllers monitor every batch, keeping the temperature within safe margins. As the glaze reaches its vitrification point, the surface transforms, becoming glossy, non-porous, and resistant to abrasion. This is the key moment of transformation from a dry, fragile clay body into a durable, finished ceramic product, ready for the final decoration or quality inspection stage. Inspection and packaging process. Once the products have cooled and stabilized after firing, they move to the inspection and finishing stage, the final step before leaving the factory. Each bowl, plate, or vase is placed under a high-intensity lighting system, allowing technicians to easily spot even the smallest flaws, such as pinholes, glaze drips, or misaligned patterns. In modern factories, thickness inspection is performed using a combination of ultrasonic scanners and laser sensors as the pieces travel along the conveyor. The ultrasonic probes emit high-frequency sound waves that pass through the ceramic walls and reflect back from the opposite surface. The computer system then calculates the exact wall thickness down to hundredths of an inch. At the same time, laser beams scan the exterior surface, creating a 3D profile that is compared to pre-programmed design data. If any area is found to be too thin, too thick, or slightly warped, a robotic arm automatically removes the defective piece from the line for reprocessing. After inspection, the products are sent to the mechanical finishing area. The rims, bases, and drain holes of sanitary ware are wet ground and polished to remove sharp edges and ensure safety in use. Finally, all approved items are stacked on trays or pallets ready for packaging and shipment. After passing the final inspection, the products move to the packaging stage, the last step before leaving the factory. Here, both workers and machines work together to ensure every item is perfectly protected. On automated lines, robotic arms place the products onto a protective wrapping conveyor, where machines wrap each piece with a thin layer of foam or shrink wrap to prevent scratches and absorb minor impacts. The wrapped items are then arranged neatly into multi-layered trays or boxes, each with dividers that keep the product securely in place. However, for smaller, thinner, or more delicate pieces, manual packaging is still essential.
Workers wearing soft gloves carefully insert thin paper sheets between items and wrap the edges with foam or craft paper for extra cushioning. Every movement must be precise and gentle to avoid damaging the glaze or rim. Once packed, each box is sealed, labeled with a traceable barcode, and stacked onto pallets. The pallets are then wrapped in stretch film, tightened with steel straps, and moved by automated forklifts to the container loading area. This blend of modern automation and meticulous handwork ensures that every shipment, even those filled with hundreds of fragile pieces, leaves the factory in perfect condition, ready to travel safely to destinations around the world. Conclusion: from the raw clay blocks dug from the earth to the gleaming bowls, bricks, and vases in our hands, the journey of ceramics is a true reflection of how tradition and technology come together in harmony. In each piece, we see more than just an object. We see the continuation of history, culture, and human innovation. If you found this journey fascinating and want to keep exploring the hidden secrets behind modern manufacturing, share your thoughts in the comments below. And don't forget to hit the like button and subscribe to The Factoring so you can join us on future journeys.